Good afternoon, everybody. Thank you for joining this afternoon's Work Zone Safety session as part of the Transportation Engineering and Safety Conference. This afternoon, this session will explore Virginia DOT's Work Zone Builder app, developed through a working relationship between Virginia DOT and the Virginia Tech Transportation Institute. Secondly, as part of this session, we are going to discuss the Pennsylvania Work Zone Safety Study, which was completed in June of 2020 to holistically review both vehicular and construction employee incidents in an effort to improve work zone safety throughout the Commonwealth. The team who worked on this project will present their research findings and elaborate on some of the critical initiatives identified through this study. My name is Brian Crosley. I manage the Temporary Traffic Control Unit out of PennDOT's central office in Harrisburg. I will be your moderator for the session. Just a quick couple housekeeping items. As with all the sessions, the attendees will all be muted. But however, we want your input, we want your questions. So please feel free to post your questions in the Q&A section at the bottom. You can use the chat feature to talk amongst other attendees as available. If you do, as you're using these features, please keep in mind that you want to try to post any questions for the group in the Q&A section. I will do my best to monitor both areas to ensure that no questions are lost, but the best way for your questions to be answered would be to post them in the Q&A session. With that in mind, we're going to move on to our first presenter. I'm going to introduce to you Mr. Michael Mollenhauer. Michael is the Director of the Division of Technology Development and Deployment for Virginia Tech Transportation Institute in Virginia. Dr. Michael Mollenhauer, as I said, is the Director. He leads a team of researchers and engineers that help customers conduct early stage deployment and evaluation of connected and automated vehicle systems. More recently, Mike is leading VTDI's efforts to partner with the Virginia DOT to develop the Virginia Connected Corridor through the deployment of V2I and V2X infrastructure, a cloud computing environment, and a variety of mobile connected vehicle applications. Mike's most recent work focuses on work zone safety interactions between automated vehicles and public safety professionals. Now, before I hand over to Mike, I'll look for questions that are posted in the QA section. I will plan on holding those till the end. We'll ensure that there's time left at the end to address these questions. So with that, I'm going to hand it over to Mike.
Great, thanks very much, Brian. Appreciate that. Just a real quick audio check. Make sure you can hear me okay.
Yes, Mike, I can hear you.
Great, thanks. Yeah, so as Brian mentioned, I'm going to talk to you a little bit about the work we've been doing recently with Virginia DOT to develop work zone safety applications, particularly those that are affected by or can support connected and automated vehicle operations. So just a little background first, the Virginia Connected Corridor, it's been about, almost eight years now since we've started the development of that. There's really two components to it. So there's a test bed down here in Blacksburg that's near our facility at the Virginia Tech Transportation Institute on the Virginia Smart Roads. And then we also have a portion of it that's in Northern Virginia that's all on public roads. And in the Northern Virginia region, we have a little over 50 DSRC roadside units deployed. And now we're in the process of putting up 11 CV2X roadside units to support the development, test, and I guess the evaluation of various connected vehicle applications. The environment up in Northern Virginia, especially, is a very congested traffic environment, a very challenging environment to operate in. And there are significant construction and work zone activities going on. And of course, work zone safety is a primary interest for VDOT, and they work very hard to try to promote safety to the extent we can. And we think that connected and automated vehicles present both challenges and opportunities for safety as they develop and get deployed. So some of our development objectives in this environment, really it's to continue that ongoing partnership and to evaluate these technologies to improve work zone safety. We want to facilitate the production and I guess provision of data that can be used by connected and automated vehicles. And we also wanted to fill in some of VDOT's gaps in their ability to source some of their work zone data, particularly from maintenance contractors. It seems to be a particular challenge in that there are a variety of different ways to do it, but I guess compliance with getting that information submitted into VDOT systems is sometimes lacking compared to some of the other types of work zone activity that's going on. And we also want to make sure we're looking at how we can develop a means for warning drivers and getting the messages out to them that the work zones are active when there are lane configuration changes, reduced speed areas, and when there are threats within the work zones, such as workers and so forth. So those are some of our development goals. I mentioned, I guess it was mentioned before, that there's this connected cloud environment. And so all the components that are on that Virginia Connected Corridor are tied together through a backbone to the VCC cloud that acts as sort of a data archiving and warehousing and provision system. We have roadside units that are connected into the signal controllers to provide signal phasing and timing data. And we have a variety of different applications that tap into that data in real time. And also again, the orange ones down here are the work zone data elements that we're working to, I guess, build out now, and I'm going to tell you about here in a few minutes. So as we have worked with VDOT, we kind of look at the needs of connected and automated vehicles moving forward. You know, the way that work zones are effectively stored in data right now, it's you know, from mile marker X to mile marker Y along route, you know, whatever the route number is, and or maybe you get a centroid and a radius that tells you kind of where that is, but it doesn't tell you a whole lot about what's there, maybe even what is happening in that work zone. And we feel like that connected and automated vehicles are going to need a bit better real-time sort of a picture of what's happening. And so these are just some of the categories of information that we think that we're going to need. And we realize that the Work Zone Data Exchange initiative that the Federal Highway Administration is continuing is working to address some of these things and the data standards. But I think there still remains a challenge about how to get and source this data in an effective and easy way. So that really kind of drove us towards thinking about, can we build an application that can be used by folks who are designing the work zones in the first place to make their life a little bit easier, but then also give us a lot more specificity and detail on the data and what the configuration of the work zone is. So we set about developing a proof of concept application, and it's kind of grown a little bit beyond that now to actually being used in I guess, beta right now, and hopefully going to be used in practice more broadly here in the near future. But it's a tablet-based application. Currently it's Android. We are migrating it to a multi-platform application deployment system so that we can deploy to both iOS, so it'll work on iPads as well as Android tablets. Again, we use it to build the work zone and then also control, I guess, the activation of the work zone, so that when you activate it, all the data flows into the proper systems within VDOT and can be used from there forward. And we're working to effectively try to help streamline the submission, review, and approval process, because right now there's a variety of ways. It could be a paper drawing. It can be through maps that have annotations on them. This provides a bit more of a common and editable form of data that can be used by both the folks who are designing, but those who are reviewing and approving as well. And so, as I mentioned before, we are working to first service the maintenance type of activities, because there's a bit of a hole and a bit of a gap in VDOT's abilities to obtain that data. And then we also, of course, want to make an application that's fairly pleasing to use and can make life easier for folks. So first thing I'm going to show you is a little bit about the design mode. So as I mentioned before, you effectively tap out an area to design the work zone. I'm going to shift over to playing a video right now. It's a pre-recorded demonstration. So we'll listen to that for a few minutes, and that'll kind of give you a feel for how you can use the application. I think we're going to walk through a little example now of how to create a work zone using the tool. You see we have a management area here in the application that has a number of different work zones that we created. These are not named very well, but they're all part of the testing process that we're going through. To generate a work zone, you click on the Create in the upper right-hand side. Give it an ID, and that will be associated with the agency and the work package for the individual contractor. And then we give it some kind of a useful name so we can refer back to it. So I'm going to call this guardrail repair. All right. And then we can generate the work zone. Gives us a map where we can go down and select the area we want to work in. If we want to search on a location, we can use the search box at the upper part of the screen. I'm just going to pick an area down here for expediency. We'll zoom down, and let's say that this little overpass right here, we want to do a little bit of work on the guardrail on the inside shoulder. To do that, I select the template for the work zone. We have a number of different templates applied thus far that have been tested and integrated into the system. I'm going to use the inside stationary operation. So that's a left-hand shoulder operation, template 4.2 for Virginia. If I save that, now it's asking me to click out sort of the extent or the range of the activity area. So I'm going to just click one first spot and then a second spot, and then I'm going to do the create. Okay, so then we get a screen that gives us a bunch of information about what the application thinks the roadway is like in that particular case. And of course, all these bits of info feed into how the work zone has to be set up in terms of the the distances between signs, the length of the buffer, and the length of the taper, and all that kind of stuff. So I'm going to leave. I think the defaults are correct that are in here. If I needed to override them, I could. I could come in and override them with what I know to be the correct information. Sometimes we find that the underlying map data sources are not always correct. So if I save this information now, it goes out and creates the actual work zone. I'm going to zoom out a little bit. And if we zoom out a little bit more, we can see where all the signs are placed. I can tap through them on this inventory view on the right-hand side. I'll tap on the first one, which is the road work ahead sign. Pretty straightforward. If I don't like where that's positioned, just kind of from where that I'm looking at it right now, if I want to change that a little bit, I can. Simply just click on the item and I drag it, and you can see that I get a little tool in the upper left-hand side that tells me the distance that I've dragged it out to. In addition, we want to make sure that the rules are being followed for the work zone setup. So if I click on that to move it to a new location, and I'll do that now. That's maybe a little bit shorter than it should be. You see I get a violation warning in the box that talks about that particular feature. It's letting me know that the distance that I've constrained that down to is a little bit less than what the work zone manual wants us to use. So I'm going to go ahead and readjust that back out so that it is within the proper tolerance, and that'll clear that error. Okay. Walking through the rest of the features here is another set of signs that are required for this particular work zone that show that the left shoulder is closed ahead. One final one that will be, I guess, positioned before the taper or the transition. So then if I go to the transition, this is going to show me where the first channelizing devices would be set up. And you see that they're aligned with the left, the beginning of the left shoulder, and it puts the proper spacing in for the speed limit and the type of roadway that we're working with. If I click on the buffer now, that'll give me information about the buffer itself, and as it leads up to the shadow vehicle and the TMA vehicle. And then if I look and click on the activity area, that kind of shows us where the activity is actually occurring. If there are additional features that I want to place into the scene, I can do that by manually placing them. And so let's say we've got a little area down here with some guardrail that sort of tapers off on the right-hand side of the road. And maybe you want to add some jersey barrier to that. I can select a jersey barrier, kind of click out the first point of where that's going to be. And it just kind of blows in an example set, and then you can end up manipulating the endpoints of that to place that feature where you want to. So I'll just leave it at that, kind of showing that we have jersey barrier on the right-hand side, perhaps protecting that area at the beginning of the taper or transition. Anytime an object is deleted, you have the option to put in notes as to why you deleted it. If you wanted to add notes, on any feature that's in here, let's say we want something about the shadow vehicle, we can tap on that, add a note, and then fill in the field with the note. And that will be saved so that a reviewer, somebody who's going to look at the design after you've saved it, can take a look at that and get a better feel for why you've made a decision you have to position things where they are. So it's I think, pretty decent tool for being able to set up these work zones and manipulate them so that we get proper, I guess, application of the work zone. And all this, of course, the underlying data for the location of each individual sign, actually all the way down to each individual channelizing device, is being saved in a data structure in the background. Now, if we want to, I guess, activate this work zone, let's say, the statuses that you would go through is that you go to the details section, and you can, of course, fill out more information about who the points of contact are that are working on the development of this work zone setup. There is a status page you can go to that shows you the current status, and we'll be coming back to that here shortly. There's an inventory page, and the inventory tells you how many of each type of sign or channelizing device or vehicle is required to support it, so that if you're getting, I guess, your team ready to go out and set up this work zone, they can use this to get a bit of an inventory. If you have roadway restrictions that are going to be associated with this work zone, you can come in and select them here. If you have any, if you want to look at the history, it's a full audit trail of any changes or modifications that were made to the work zone over time, or anything like deleting or adjustments. So the way we thought about working with this is that the contractor would do the development of the draft work zone, and then it would be submitted for review. When we select submitted for review, that sends a copy of this, or at least sends a link to it, off to a VDOT reviewer. The VDOT reviewer would review it, could potentially make modifications or additions or changes to it. And then once they've approved it, it can go into a pending state. Once it's in a pending state, we have some automated data transfer functions that are working in the background to develop I guess a JSON data structure that can be forwarded to something like a work zone data exchange or to our TOC operators, so that they can approve it and integrate it into the other systems that VDOT uses to manage work zones. And that pretty much just lets us know that within the next couple of weeks, this work zone is likely going to become active. If I take it to the active state, which is the next state, it asks me for sure if I want to do that or not. I go and activate it. Again, another set of processes are kicked off on the server in the background, where we create, number one, we update the data definitions for the TOC and for a work zone data exchange feed if there's one available. And then we also create connected vehicle messages that will start showing up on our Virginia Connected Corridor system, so that anybody that has an equipped vehicle or a mobile application that can receive that data would get information about it. We'll see that once we've activated it, we get a new option out here on the management page, which is the workers present flag. If I turn that positive, it saves that information, and we'll get additional information in the messaging that comes out. So all the messages will be updated that there are now workers present on that work site. I think we're going to walk through a little example. Stop there. It gives you a feel for how the design mode works. So we did talk about the statuses on the management mode. And again, those are for actually, I guess, initiating the different stages of work zone deployment and all the way through the canceling or completion of it at the end. So again, as we mentioned, when it goes active, a couple things happen. The data definition gets stored to our server and then gets converted into messaging and data components that are then used by other parts of our system. So we get geofenced areas defined for where the activity area is, where the buffer area is, and where the transition area is as well. And I'll tell you why we do that here in a few minutes when we talk about a different component of this process, which is a smart vest. We have automated traveler information messages are then also deployed. And again, for right now, there's not a whole lot of connected vehicles running around out there in the world, but I'm hoping with some of the recent announcements from the FCC about effectively picking a winner, if you will, between C-V2X and DSRC, that'll take away some of the technology uncertainty, and we'll start to see more of those types of equipment deployed in vehicles. But what we're doing here is in automating the message development and deployment when it goes active, so that those are available as geofenced areas. So if a connected vehicle rolls over that particular spot and they have retrieved those messages from the system or receive them, they would get proper messaging that they could display on an integrated display within that vehicle. There are potential for aftermarket types of applications or mobile applications that can do the same. In addition, we've looked at automated performance assessment for the work zone as well. So we have, again, assuming that there are connected vehicles out there in the future, the connected vehicle would go over a particular region in the work zone, and it would be asked to reply with a set of data that kind of gives its status. So what its speed is, which lane it's in, and then we can use that to do automated assessment of the work zone as that data comes in. I mentioned before the geofenced areas. Another product that we're working on with VDOT is the VCC Smart Vest. So this is a wearable that can be used by workers within the environment. It has 2 speakers up near the shoulders so that you can hear them quite easily. It's got LED strips that light up when we want a message from that vest, and then also 4 vibrotactors that give a vibration that provide nice directionality, so you can get a feel for where I guess the message orientation is. So if there's a threat, we can kind of give a direction as to where that's coming from. The device itself has an XB mesh network component in it that talks to a base station that's at the work zone, so that you can consolidate all of the, I guess, the locations and the communications between the individual work vests together in one spot before they're sent up to the cloud and then further used for messaging both for drivers and for the individuals. It's also got GPS and inertial measurement unit to locate the individual within the work zone, and it's fully programmable so that you can define different kinds of message responses from it. So to give you an example of it, what it looks like, this is a video where we have a worker who's actually coming into a boundary that's defined between zones, and as they work towards it, they'll get, I guess, a warning on the right side indicating that that's where the boundary was that they're heading. The idea behind this is you can both define a geofenced area within a work zone that is effectively a safe area, and if the worker strays from that, they'll get some messaging, and you get really kind of two levels. So one is I'm getting close to it, maybe within a meter, and the second one is that I passed through it. When we consolidate all this data at the base station and then send it into the cloud, or if we broadcasted this information from that base station with a temporary or remote RSU out to the vehicles or connected vehicles that are driving by, you can then give messages and do collision imminent warnings between the vehicle and the individual. So it's not just the passing vehicles, but it's also the geofenced areas. So we do both types of messaging, and we have a different pattern for how we, I guess, light up the lights and provide the warning sounds and the vibrations to the individual so that they can hopefully tell the difference between the two and understand what they're being warned about. We are doing a fair amount of testing of this right now with real end users to understand, what they feel about the comfortability of wearing this device. It's actually quite light. We have another iteration of it that's going to be ongoing here shortly to make it even lighter and give it longer battery life. So we're looking forward to that. And then we're also looking at effectively adding kind of smart cone devices. So these would be a little object that you would place in the top of the cone that also has that XB wireless mesh network component that will help further define the geofenced part of the work zone, but also it helps expand the networking capability. So the more of these devices are in a mesh network like this, the more reliable and better the communications are. So it helps to supplement a little bit with a few to avoid any shadowing between, say, where there's equipment or other features within the work zone that might block a good transmission line of sight between the receiver and the wearer of the vest. I mentioned before maybe a little bit about the field mode of the work zone builder. So we're talking about the tablet application again. So an additional feature we have is to be able to use it to set up the work zone in the field. So you can get navigation directions to where, let's say, like that first warning sign is that you would set up, and it would give you a countdown of distance as you approach the particular spot where you're supposed to do the placement of that sign. Same with all the other features where a taper would start, where a taper would end, and then details about how the spacing should be so that you have that all kind of right at your fingertips as you're setting up the work zone. If you get out to the field and you find that you've got maybe like a line of sight restriction or something that you didn't plan for when you were just looking at the map and building the work zone, and if you want to alter the geometry of that work zone, you can replace those features. So effectively, you move your vehicle to where you really want to place a sign, and then you say snap to this location, and it would update the plan and keep it updated so that an inspector could look at it and understand where and how it was actually set up, and any notes that you might have put in about why you've changed the placement. In addition, you can capture imagery, so we can capture pictures about where things are placed and how they've been set up to further document what that looks like. So the status of this development, we're effectively going on to another, I guess, about a 6-month development process. Again, doing the port from having it be just an Android-only device to also supporting iOS. The Virginia DOT recently made a decision to distribute iPads or Apple technology to all of their field workers, so we had to do a quick pivot there to try to make it multi-platform, which is fine for us, but it's a little bit of work to get that done. We're going to continue to expand the number of templates that are supported within the tool, and we're also implementing a more complex set of user administration and roles so that it matches better the workflow that you would see as work zones are developed, I guess, and approved and deployed. We're going to add this field mode functionality and then finish the integration with some of the other VDOT systems. VDOT's in the process of updating those systems, so they asked us to hold off until they were installed and in place, and then we would look at how we can do the finalization of that integration. And so we've been doing some beta testing with VDOT contractors, been getting a lot of really good feedback about the usability and where some of the challenges are with the tool. And we're also trying to address those in the coming year's development. And then also, as you see, we'll hopefully be wrapping that up in about the June timeframe, and we'll have a much more feature complete product that's ready to go out for the final beta testing before broader deployment. So that's kind of what I was, some of the initiatives that I had wanted to speak to you all about. I'm hoping that if you have any questions, I guess we'll, Brian, if you want people to wait till the end or answer them now, we can take them however you like.
Yeah, I think at this point, we're going to hold them to the end. Right now, we do have one question in there, and I may ask one myself. So, Michael, I thank you for giving this presentation to us. It's very valuable information. I think it's just like Virginia, Pennsylvania, I think you can say we'll be looking to explore similar options moving down the road as we get more connected and autonomous vehicles out there, as well as communicating to our current applications such as Waze, Google, and the like. So I thank you for this. It's very valuable. And yeah, I'll be back to you here at the end with a question or two. So with that, I'm going to move on to my to our next presenters. First person I'm going to introduce you to is Keith Meehan. Keith Meehan works in the Traffic and ITS division of Michael Baker International. Keith is a licensed professional engineer within Michael Baker's Tolling Services division and specializes in traffic engineering and operations. Keith joined Michael Baker in 2012 after graduating from the Pennsylvania State University with a bachelor's degree in civil engineering. Keith's experience ranges from traditional engineering studies, designs, and operations to policy development and program implementation. Currently, Keith is an assistant project manager for the Pennsylvania Turnpike's General Consultant Engineering contract supporting the Commission's Traffic Engineering and Operations Department in technical expertise as well as business management. His role at the Commission has included leading or co-leading efforts such as the Work Zone Safety Subcommittee, the development of PA's statewide automated work zone speed enforcement program, statewide crash segment evaluation, CAV working group, and the traffic operations subcommittee. Along with Keith, we have Brian Link. Brian Link is a project manager with Michael Baker International. Brian is a licensed professional engineer and is a safety certified transportation project professional. Like I said, he's employed with Michael Baker International. His experience includes task and project management, cost estimating, construction management and inspection, utility coordination, plan and specification development, design build project development, selection, administration, and execution, and open-end advisory services to transportation facility owners and operators. Brian has fulfilled roles as a contractor, designer, and owner's representative on various transportation projects for public and private owners. Brian is active in industry and public agency safety committees focused on improving the safety for employees within the surface transportation industry. So without further ado, I'm going to hand this over to Keith and Brian.
Thanks, Brian. So welcome, everybody. Today I'm going to go over, Brian and I are going to go over the Pennsylvania Work Zone Safety Study. We did this over the course of the past year, finished it up in this past summer. The idea behind this was to look at, in general, work zone safety across the Commonwealth. This stemmed from out west. There was a question about how we were recording specifically worker incidents and contractor incidents. So we do a really good job as far as PennDOT does a really good job of tracking their internal, employee incidents in work zones. But how are we evaluating contractor incidents and injuries and doing mitigations to kind of solve those problems there. So that's where this stemmed from, and we'll kind of walk through where this project led us. So with that, trying to see if I have control. Give it a second. There we go. All right. So two of the goals that were part of this program or this initiative were improve policies and procedures related to collecting and retaining highway work zone safety data, that kind of looking for the gaps, I guess, that PennDOT doesn't have data on currently. And then also improve traffic or temporary traffic control and highway construction employee safety practices.
Hey, Keith, I'll just advance.
Okay. Yeah, it's not going for me. Go ahead. So I'll kind of give you a brief overview of it. So we looked at crashes and construction employee incidents between 2015 and 2017. Go ahead, Brian. We prioritized incidents with a max severity level, so severe injury or fatality. We were identifying gaps in the data for future improvements, focusing on identifying tangible improvements for PennDOT's power to effectively implement. This is what we wanted to do, is focus on things that PennDOT, were able to change within their purview. So we don't want to focus on utility workers or accidents that just kind of happened at random. I wanted to see what actually PennDOT could make a change to, and then try and put a mitigation towards that. And then propose metrics and implementation plan for each one of our recommendations. That way there's a roadmap for PennDOT to follow. Overview, and this is a little graphic of kind of the total project. This is all severe injuries and fatalities over that 2015 to 2017 period. So 174 of those were vehicular crashes only, 49 were worker incident, and then there were 6 incidents that kind of crossed that overlap between that vehicular and worker accident. Just kind of a little background as well. We know that there are obviously several efforts from PennDOT as far as improving the safety of our work zones. So this project was to kind of supplement those and add additional recommendations on top of those. We didn't want to, rehash anything that was currently already going on. So I'll give it over to Brian here for construction safety.
All right, just quickly, I wanted to emphasize the pie chart that Keith showed was for severe or fatal employee accidents. So that's not all recordable incidents. So we're leaving the comforts of the traffic world and going into what's often more of a contractor's world, the OSHA 1926 regulations, what's governed by OSHA. That has been the focus of this part of the study, is the highway contractor incidents and injuries. So OSHA actually, the state of Pennsylvania chooses not to follow OSHA. So OSHA doesn't regulate state employees. So these are accidents and incidents by private contractors, consultant inspectors, or if Federal Highways is out there, they're also governed by OSHA. The sources that we leaned on, we had looked at what PennDOT is tracking. We decided that for consistency and just total data set quality, we went with OSHA reports of severe and fatal incidents. And then the Bureau of Labor and Statistics and PA Department of Labor and Industry both report on recordables as well. And the data we reviewed was severe injury and fatality reports, which give you more detail, and then incident rates, which are more aggregate. So this is the clearest I could get on what the OSHA reporting is. Unless you came from the contracting industry, you probably are scratching your head. The key for OSHA recordables are, was there a hospitalization, amputation, loss of an eye, or did someone die from injuries or illness within 30 days of the incident? I guess if you died in 31 days, it's no longer an OSHA recordable, or it's not a fatality from the workplace, but those are what are covered by those severe injury and fatality reports, which give us more granular details. And then below is, did you miss work? Did you require medical treatment beyond first aid? lose consciousness, or went to light duty, had job transfers. So those are called recordables. Those end up in the incident logs, but there isn't that detailed per incident report that is publicly available. So these are the reports, or this is a table that summarizes the reports that we were able to review from severe and fatalities, severe injury and fatalities. I wanted to highlight two items. The struck by vehicle within the work zone resulted in 2 fatalities, and struck by vehicles from the motoring public resulted in 2. So that 4 total over the 3-year span, isn't a landslide necessarily, but you can see these are kind of the most severe incidents, and these are kind of where we thought PennDOT could affect better change. I did, since Mike presented earlier on that Smart Vest, I did want to highlight falls and slips is like consistently one of the higher rates of severe injury. And there's a push in the industry to actually use helmets instead of the traditional hard hat, which protects from blunt force trauma from falls and slips to the head. Those are about $100. So if you guys are gonna start deploying $100 vests or cones, I would say go after the helmets. That's gonna do the most good in the short term. I'll get off my soapbox, but that's my my thing there. Now these tables summarize the incident rates. So these are aggregate numbers. We don't have the granular what happened in each report. We looked at 3 years, federal and state. So Pennsylvania L&I reports up to the BLS. So there's symmetry in the data there. We didn't see any major trends show up at that level. So Pennsylvania sort of tracks as the nation goes, electorally and from a safety standpoint. So I also want to highlight here the NAICS code 237 also includes, it's heavy civil engineering and construction, but it also includes utilities, those sort of pipeline sort of activities as well. Those also are classified as heavy civil. For the severe injuries and fatalities, we can go more granular to the 2371, which is just highway and bridge construction, but BLS and L&I don't report to that level of detail, probably because then you can start pinpointing very specific contractors. Again, one level up, and this is the most granular data we could go on employer size, but we wanted to highlight here, there's a clear differentiation in incident rates between the number of employees. So actually 1 to 10, they don't have to report per OSHA. They have to follow OSHA guidelines, but they don't have to report. That's why there's no data there. But employers in that 11 to 49 are experiencing a much higher rate of incidents. So the best predictor of whether you're going to get injured on a job is how large your employer is, which was a finding we wanted to highlight. So recommendations. The first is to begin tracking some of these metrics to make sure, for like the PA relative to the federal, that we're in line, we're doing better. Also to be looking at these severe injury and fatality to see if there's any kind of red flags that are showing up. So that's using the publicly available OSHA, BLS, and labor and industry data. Then we also wanted to focus in on that employer size and have PennDOT partner with the APC and ARTPA, so the contracting lobbyists in the community, and also using the PADBE and PADB and the PennDOT DBE program to try to drive down some of the resources that larger employers can provide through corporate safety initiatives, doing that through the organizations and the DBE support structure. Finally, and this was a subject of industry stand down in October, industry and PennDOT stand down in October because of accidents from line of fire, people getting struck by equipment, is incorporating internal traffic control plans. And internal traffic control plans are, you know, behind the barrel type plans. So the MPT, we have a strong grasp on what works, what doesn't work. The ITCP is looking at activities behind the barrel, making sure we're not putting employees in harm's way. So here, this is an example of placing embankment. So it's showing areas where personnel on foot can go, where flaggers should stand. You know, the no-go areas, no crossing in front of the dozer, no crossing in front of the grader. And these are helpful too for people who aren't on site every day as well. So site visitors, on larger projects, I've seen this done, and you have to do a site-specific safety review before you go into it. So there's a lot of resources. I put a link here, workzonesafety.org has a whole manual on this. So turn it back over to Keith.
Thanks, Brian. So switching back over to the vehicular side. So Brian talked a lot about the behind the barrel, this kind of, you know, going back to traditional MPT type of thought process. As so we utilize the data from our basically 3 different areas. There's the PSIT and FARS. So PSIT is PennDOT's, you know, and most of you probably are aware of it, and PennDOT's crash analysis, and FARS is the national level of that. Go ahead, Brian. Crash reports, so PennDOT crash reporting system, and that's police reports, law enforcement reports. You can really get a lot of information that doesn't really show up in that crash data to get, that's, you know, if you read through those specific reports. And then finally, also kind of reviewing those temporary traffic control plans, ECMS need permitting that were available to us. We focused our efforts when reviewing that on, you know, if there were lane shifts that were a cause of the problem or were specifically detectable out of, you know, reviewing the crash data or crash reports. So wanted to highlight like one of the ones that we found. This occurred on a 55-mile-an-hour roadway where as it was a typical, I should say, typical posted speed limit, regulatory speed limit of 55 mile an hour. However, this bridge being constructed with the temporary road was actually designed at 35 miles an hour. They did have all the signs, you know, reducing the speed, but, you know, kind of that with a person not knowing or familiarity with what's going on, drove and crossed over and hit a head-on collision, causing a fatality, which is one of the reasons why PennDOT, you know, has changed its policies towards their designing at a regulatory speed limit, and that they just, I think, sent out this summer or the past summer. So looking at through those, that was the gist of trying to really kind of dive into what's actually going on out there, going that not surface level, but going a little deeper into the analysis of these severe injury and fatalities. Could kind of hone in on some recommendations. So Brian, if you want to move to the next slide. So some key findings through our analysis. Speed differential was a big one. 46% of our fatal incidents were some form of speed differential, whether or not that was, you know, running into the back of a vehicle in a queue, or actually trying to avoid the queue and running off the roadway and ending up, you know, rolling the car or whatnot. 60% of the severe and fatal incidents were rear end, so you know, huge. And then increased severity of rear end crashes in the advanced warning areas, so where your advanced signs are. Actually, when you have a rear end occur out there, the increased severity level, and that's, I mean, I don't want to say common sense, but it makes sense in that it's unexpected. It's usually then you don't get necessarily the signs. You're not naturally in a work zone. You don't think about it, and all of a sudden you run into stopped or slowed down traffic. Traveler exposure to work zones. there was a spike that we saw the 2 to 3 p.m. There wasn't necessarily anything as far as a trend in why 2 to 3 p.m. that you could see through the data. You think about it and you say, okay, people that might be right when you start to see slowdowns out on the road due to traffic starting to increase, people starting to head home from work. But we could see that happening. So, and then 6 workers struck by motoring public when they're working near the lanes of traffic. So again, this is all dealing with the idea that if you don't have a worker out there, you don't have a work zone out there, you're not going to have work zone incidents. Or if you do your work when the less traffic is out there, you're going to have less opportunity for that an incident to occur. And then finally, some vehicular trends. 44% of fatal crashes involved commercial vehicles. 87% of those were large trucks. So some recommendations that came out on the vehicular side. The first one was, this is if you saw Tom Mashoni's presentation from earlier today, developing a work zone safety committee at PennDOT. The idea behind this is to bring together similar kind of a sister program to the Turnpikes program, and do that collaboration where you break down walls and barriers between the different departments, maintenance, design, and construction engineering, and collaboratively work together to try and improve safety. The work zone operational efficiencies, that's where I talked about how less work out there, or improving operations to get you on and off the road as quickly as possible, trying to combine any kind of work that you can, or anything to get, or working during off-peak hours, all will help to reduce that exposure to work zones by the traveling public, and have an opportunity to reduce that potential for crash. Smart work zone technology. So this comes from we see a lot of those rear end crashes, and that's primary cause of our incidents in work zones. So knowing like queue detection and where it was, or I guess where I should say traditionally, where we have radar or Wi-Fi, whatever we use to detect that slow moving traffic now, with the development and deployment of ATMS systems, we can actually use the INRIX data that can track speeds, automatically detect, as within a certain threshold that speeds drop. And if we have our DMS boards that are out there and they're connected to a main central hub, that ATMS system can automatically send out an alert and say, hey, slowing traffic, or even stop traffic, and getting the word out there to that driver is critical to kind of preventing those rear end crashes. And then finally, commercial vehicles, again, 44% of the fatalities involved with those heavy vehicles. And I think is both on creating awareness for the commercial vehicles, but I think a lot of them are well aware. I think this is also a duty of educating the public to say, when you're in a tight space with barriers on both sides, it's not a great idea to try and jet past a traffic or a big old truck that has very limited, room to maneuver, especially if they get a big gust of wind. They can offset them by a foot or more. So that's I think that one where we were aiming towards is probably a public education. So with those, there were other ones we came up with about 15 recommendations. Those were kind of the key ones that we wanted to talk about here. With that, Brian and I will take any questions that the group has.
Keith and Brian, thank you so much for that presentation. I'm sure everyone got a lot of information from that. And Brian, I appreciate you bringing up the safety stand down event that was held this past fall. I was going to actually bring that up, but you brought that up I appreciate that. And again, for those of you who don't know, because there was an increase this past construction season regarding what we call line of fire incidences where, construction personnel were being unfortunately struck by their own internal, construction equipment or vehicles. APC in conjunction with the department took the time in October, the first Monday in October, to basically encourage everyone, all their business partners, to take a couple, half hour to 2 hours out of their day and just talk about the risks that were involved, because they were getting the end of the construction season, all hands on deck, trying to get everything done before the winter shutdown. And unfortunately, sometimes complacency creates issues, and unfortunately, people get hurt sometimes. So because of that, we foresee in the future having additional sessions, maybe midway through the construction season. So those are conversations we'll be holding here at some point throughout the winter months. But with that, I want to take time to answer or post the questions to the panelists for them to answer. So question number one, Michael, the question is can the vest be equipped for work zone intrusion warning, so if a vehicle does intrude or invade into the work zone, that the worker can be warned?
Yeah, the answer is yeah, that is one of the elements that we're planning to support, including, so it's not just intrusion from passing motorists, but also things like backing incidents with equipment that's in the work zone as well. So we're kind of working out the details for how you would best equip some of the equipment, particularly equipment that's coming to and from the work zone that maybe is not part of the activity, right? It might be a subcontractor, it might be from a different facility. So is there a way to temporarily set up those vehicles so that they can be instantiated into the system and accounted for in the warning algorithms that'll be running on that base station? In addition, yes, with the concept of the base station where you're consolidating all of the, I guess, the individual's locations in a single spot, yes, you would look at intrusion warnings. So if somebody's crossing a line of cones or somehow getting in and there is a potential intrusion, then yes, you would warn through the vest as well. We have done a little bit of work on those algorithms, in particular the equipment more, I guess, more acutely is what we've been working on for backing or run over kinds of incidents. But I think you're absolutely right. There's no reason not to do the intrusion warning as well.
So I'm going to kind of ask a follow-up that goes along with that. Then can it be used in conjunction with the Builder app?
The vest?
Yes.
Yeah. So yeah. So if it wasn't clear, one of the slides that I showed after, when you publish and put the status to active, it does generate the boundaries of the work zone, and those become the sort of default geofences for that work zone. So if you have an activity area, right, it will basically give you the four corners of that. If it's a square, right, a location, if it's around a curve, it gives you more elements of the polygon. So then that gets automatically loaded down to the base station and becomes the activity area boundary, effectively, that will be in effect at that work zone while it's active.
Okay, thank you. The next question pertains to your Builder app, Michael. Are automated lane closure systems integrated within the work zone Builder app? So for an example, and I think Keith could relate to this with his work on the Pennsylvania Turnpike, is if you have automated gates or gating systems on the infrastructure, would that be integrated within the work zone Builder app?
Considered that. We made it a little bit lower priority, given that we're the type of folks we're trying to support and get out into the pilot first. I would say no, they're not today. I would say moving forward, they will likely be. One thing that we're looking at, and some of you may be aware of, that we're looking at further integration with is, so the type of design that we're doing with this tool is fairly straightforward for the more maintenance type activities. But for some of the larger, more complex work zones, a different mechanism might be better for documenting what's there. So in that example, the Collision Avoidance Metrics Partnership, or CAMP, it's a collection of OEMs, they have developed a work zone recording or capturing tool. so that you can drive through a work zone and then mark the features that are in it effectively longitudinally along that work zone. And that would give you the ability to go out and I guess collect what's there without having run the design through the tablet-based device. So there are places where I think it's appropriate to use the tablet. There are places where it's probably not. And so I think we're looking at integrating in some of the camp tool set into our field mode so that you could go out and actually capture one that you really didn't even design, right, with our tool, but it would still publish all the same data and push all that through the same process. So that might be a better way to handle something like that.
Okay, thank you. So the next question, I'm going to assume also revolves around the Builder app. If queuing is detected, will a detour be presented within the announcement?
I think we view the system as being a provider of data for others to collect and operate on. So again, with that base station having a link to the cloud, we do have a public API where somebody like a Waze or some other mobile app, or maybe an OEM comes out with an app for their own routing systems, they can get the information and they can choose whether or not to do the rerouting. I think us doing the rerouting is probably a reach, for the kind of things that we want to be able to support with the application. If we're broadcasting locally from the intersection over an RSU, then the opportunities given the range of that roadside unit for being able to broadcast are somewhat limited. So I would think it would have to more go through the cloud to be able to really be useful. But I would say that the conduit for the data and the data are there. It's a matter of somebody else being willing to come in and pick it up.
Okay, thank you. Keith and Brian, first is a statement with a follow-up question. So the statement is, one of my crews was involved in a work zone intrusion today. 2-lane, two-way roadway, channelizing devices were in place. A tractor trailer or commercial vehicle hit several safety cones and made what was thankfully minor damage to the broom and operator. So obviously an intruder and struck a piece of equipment. The follow-up to that is, could these mechanisms work in this incident?
Sorry, I was off, or I was on mute. I think, well, Brian can talk about internal traffic control plans that might, keep that kind of barrier, that buffer a little bit safer for any kind of employees on the employee side. But yeah, work zone intrusions are definitely a problem. That's something that I know the Turnpike is trying to get a better grasp on, and PennDOT, to try and track those. And a lot of times you have everything set up correctly, or it might be just something that was just tweaked. Maybe the barrels are a little bit too wide or along those lines. And someone gets confused. A lot of times it's just a confused driver late at night, and they follow, a worker vehicle into the work zone. And so work zone intrusion, as far as trying to implement, different mitigations, there, as far as preventing them, it's keeping up and trying to apply standards as best as possible, so people are, it's kind of one of those things that people know what to expect in the work zone, and then as long as each work zone is the same from one to the next, then most people will follow it and know exactly what to expect. But yeah, work zone intrusion, I will say, we don't have a good mitigation for currently, but that is something that I think a lot of people are trying to work on to figure out how to lessen that.
I'll just touch really quickly. The internal traffic control really helps prevent internal equipment, so equipment within the work zone, from hitting other workers. I don't know the circumstances of this incident, but it can also define sort of no areas. If the MPT is set up and you have a buffer zone, it can also define that your workers shouldn't be entering that buffer zone. You shouldn't be, so that could, I don't know that is an issue for this incident, but that could provide more clarity to allow for, that buffer zone to stay clear, or have a TMA there or whatever. So That's all I have.
Yeah, thank you guys. Next question for Keith and Brian as well. Was crash data distilled to type of roadway facility, type of traffic control, via long-term versus short-term, to determine any trends amongst setups of various types of facilities?
Yes, we did look at that. You know, on police reports, it's not necessarily part of their queryable data. So reading through police reports, we did, you know, I think it was roughly about 70% of the crashes that we could identify if what the traffic pattern was about in stationary operations, because you got to think only a portion of these actually have temporary traffic control plans. You know, those are your type of long-term construction versus a lot of these are just, you know, short-term lane closures. They follow a PATA figure and they go out, they set the road up, or it's a mobile operation. So we had about 70% of the ones that we could determine which ones. We had about 70% were stationary versus 30% were mobile operations. We didn't have any necessary trends. I would say they were pretty split as far as left-right lanes. But I will say that we did, I think it was roughly 80%, 70 or 80% of our crashes, fatal and serious injury crashes, were on high-speed roadways. Obviously, you increase the speed and you're going to have more serious injuries. So.
Okay, thank you guys. The last one here is, I believe, more geared towards myself, so I will answer this question. And that should about do it for our session for today. So before I answer this, I want to thank the three of you for presenting and taking the time to participate in this session. It's very invaluable information, as I mentioned before. So the last question is for the folks for PA. Do you foresee development of a separate smart work zone guide for designers? And if so, will it be incorporated into revisions to existing design documents? As I was thinking about this session here the other day and prepping for it, that actually came to my mind as well. So one thing I will say is we are currently, the department is working through the development of a chapter in Design Manual 2 related to temporary traffic control and developing traffic control plans, and certainly smart work zone applications would also be part of that. Now, however, you know, moving forward, much like what Virginia DOT did in collaboration with Michael and VTTI with their Works on Builder app, you know, I could foresee us, you know, as we move down the road and we start exploring and developing these similar practices across the Commonwealth, that there would be a potential need to develop similar documents or publications. So things that we definitely need to consider and we will be discussing in the coming months. So I appreciate that question. That was a very good question. So that does it for us, guys. There's no more open questions. And again, I want to thank you guys for your help and your presentations. And I want to thank all the attendees as well for participating in today's session. So we hope you enjoy the rest of the Engineering and Safety Conference, and we look forward to seeing you all very soon. So thank you.